Good day everyone. Today we shall be considering sequence and series, popularly known as AP and GP. By the way, this is Gifted Brain, aka Saizu, first in Africa, sixth in the world. Please, if you are yet to subscribe to our YouTube channel, do well to subscribe and then do well to on your notification button. Both activities are just free so that you can be notified when we drop another tutorial videos. So we are considering sequence and series today. And what is sequence? Sequence is an arrangement of a set of numbers which follow a particular mathematical order or rule. I see this sequence can be divided into two. We have the linear sequence and we have the exponential sequence. Another name for linear sequence is arithmetic progression. Arithmetic progression, or you say linear progression. So that is for linear sequence. And what actually is a linear sequence? A linear sequence is a sequence in which every term is obtained by adding or subtracting a definite number to the preceding number. That's a linear sequence. You see, for instance, now let me say we have 1, we have 4, we have 7, and we have 10, and we have 13. As you look at these numbers now, what do you notice? What is happening? We keep adding 3 to the previous number. That's an example of a linear sequence. Another is, let's say we have 12, and then we add 7, and then we add 2, and then we add -3, and then we have -8. Now, as you look at this sequence now, what do you think is happening? Yes, please, nothing like plus here. That's a mistake. It should be a comma. Okay, what do you think is happening now? We can say we are subtracting 5 to get the next term, but 12 minus 5 will give me 7, and 7 minus 5 will give me 2. Or you can say you are adding -5 to get the next term. Add -5 to a term to get the next term. So that is an example of a linear sequence. One of the things we want to consider in a linear sequence or arithmetic progression is the end term of an arithmetic progression. You know, like this sequence I gave previously, we said we had 1, 4, 7, 10, 13, on and on. You know, I want to take note of something here. You see, this 1 we have here is called the first term. The 4 is the second term. The 7 is the third term. And the 4th, you write it T with a subscript 4. The 13 is the fifth term, and we can have several terms like that. Now, I want you to take note of something. This word called the first term, the T1, the first term, which is the T1, is actually represented by an A. T1 actually represented by an A. So instead of saying T1, you say A. Now the T2 is the second term, third term, and fourth term. But the first term, so anytime you see A in whatever series or sequence it is, it means the first term. Now, again, is what we call the common difference. The common difference is that number you keep adding. That's the common difference. Or that number you keep subtracting to get the next term is the common difference. And actually, the common difference is given as either you say T2 minus T1, or you say again it is T3 minus T2 minus T2, or you say it is equal to T4 minus T3. This is telling you that a term minus the previous value will give you your T2. That's what that means. So, and we represent it by a D. So when you see D, it means common difference. And so, you know, if we want to get the end term of an AP, how do we do that? Now, take note of this sequence. Now, let's derive the formula for the end term of an AP. Now, look at this formula. So, this should be 4. So, let me correct that. 4. And then we add 7, and then we add 10, and 13. Now take note of some things here. Like I said, this is the A. To get this 4, what I just needed to do is to say 1 plus 3, and 3 is the difference. So we can say this A plus D. To get this 7, what do I do? It is 1 plus 2 of the 3, which is A plus 2D. Now, to get this 10 here, how did I do that? It is 1 plus 3 of the D, and that gave us A plus 3D. Now, to get the next term again, which is 13, how did I do that? 1 plus 3, 4D, 4D. And 1 for 4 into 3, which is 1 plus 4D. Now, take note of something that, this is the first term, which is the T1. This is the second term. This is the third term. This is the fourth term. And this is the fifth term. Now, take note of something. To get the second term, it is A plus D. To get the third term, it is A plus 2D. To get the fourth, A plus 3D. Something is consistent there, the A. You say A plus something. But look at what we are adding. That A plus what? For the fourth term, A plus 3D. For the fifth term, A plus 4D. It means that if I'm going to get the sixth term, for instance, obviously I know what it should be. It should be A. So this should be A, not 1. A plus 5D. If I'm getting the 20th term, T20, it should be A plus 19D. This is how we get the n term of a sequence. It means that the n term of a sequence, whatever term you are looking for, it is A plus n minus 1. Since if it is 20, it is 19. If it is T30, it is 29. If it's T25, it is 24. That is n minus 1. So you just minus 1 from the whatever your n is and multiply by D. This is how we got the formula for the n term of an AP, and we take an example on that. For this example 1 now, find the 20th term of the AP given 1, 4, 7, 10, 13, on and on. So all you just need to do is to say A is giving us 1, and then the D, which is, you can say T2 minus T1, which is the A. And so T2 is 4 minus the T1, which is 1, and that gave us 3. And so, and our n, since they said you find 20th term, our n is 20. So we can say the T20, 20th term, is equal to A plus 20 minus 1 from our formula, close bracket D. So T20 simply is equal to our A, which is 1, plus 19 multiplied by the D, and the D is 3. So if we do this, we would have 58. So that's our answer. For this example 2, we say find the 15th term of an AP whose first term is minus 12 and the common difference is minus 5. What we just need to do is to bring out our parameters with the things we are given. So our A is minus 12, our D is minus 5, our N is 15, and then we use our formula. And so just put in your value. Your T15 will simply be A minus 12 plus open bracket, we would have our N, which is 15 minus 1, close bracket, multiplied by the D, which is minus 5. So at the end of the day, we will have minus 82. This is our final answer. Let's take example 3 now. Okay, so on and on, we can get we don't know our n, that's the point. We don't know our n for this question, but we know our Tn. Our Tn is given in this question to be 440. So we can say that from a formula for Tn is equal to A plus n minus 1, close bracket D. Put in our values now, the values given to us. Talking of value, we look for n here. So our n will give us 146. So that's that. Let's take example 4. Example 4 says the 12th term of an AP is 4 times the 4th term. Find the first term in terms of D. First of all, is to establish the condition given to us that the T12 is 4 times the 4th term. 4 times the 4th term. Again, what's your T12? T12 will be A plus N, that is 12 minus 1 now, close bracket D. It's equal to 4 of the 4th term, which is A plus 4 minus 1, close bracket D. Yes. And so quite easily done. We can say this A plus 11D is equal to 4 into A plus 3D. And then A plus 11D is equal to 4A plus 12D. And so we can say 11D, or 11D minus 12D, let's continue, is equal to 4A minus A. All I just did is to bring the 12 to the other side, 12D to the other side, and bring the A to this other side. So this will give me minus D is equal to 3A. And obviously, dividing both sides by 3, A will be equal to minus D over 3. So that's all for this question. Let's take example 5 now. Example 5. The 4th term of an AP is 13, while the 10th term is 31. And there's a mistake here, words are repeated twice. So, okay, find the common difference, the first term and the 30th term. Well, given here, what we're giving here is the T4 is actually equal to 13. And we are told again that the T10 is actually equal to 31. And so we know that T4 actually should mean A plus 3D. So we are saying that A plus 3D is equal to 13. This gives us equation 1. Again, take note, how do I know it's A plus 3D? Remember now that T4 will mean A plus 4 minus 1 into brackets, then multiply by D. Recall again that, you see, T10 likewise will give us A plus 9D. That is our T10. And again, they say T10 31, yes, so it means that A plus 9D is equal to 31. And that gives us our equation 2. So we can simultaneously solve equation 1 and 2. Equation 1 is simultaneously solving simultaneously. So what we would have is A plus 3D being equal to 13 and A plus 9D being equal to 31. We can choose to subtract these two equations. Equation 1 from equation 2. This is equation 1. This is equation 2. Subtracting equation 2 from 1. 2 from 1 actually. So A minus A will give me 0. So 3D minus 9D will give me minus 6D. Please, this is 31, not 3. And then 13 minus 31 would give us minus 18. And so from there we can divide both sides by minus 6. We've gotten our D now to be equal to 3. We can go ahead to get the A. We can put the D we got into any of the equation. Let's put D into equation 1. We know equation 1 says A plus 3D is equal to 13. Obviously, since we've gotten d to be 3, a plus 3 into 3 will give me 13. And that means a plus 9 is equal to 13. So we can say that our a is equal to 13 minus 9. And that gives us 4. So we've gotten our a now. The next thing is to get the 30th term. Obviously, T30 should be equal to a plus 29d. 29d. Obviously, our a is 4 plus 29 into 3. If we do that accurately, we have 4 plus, this will give us 87. 29 times 3, and then our answer is just 91. So that's that about that.